Hello, I am Anil Kumar. Today is our class on rational functions. We had been working on rational functions for last two classes. We have seen what reciprocal functions are and the characteristics and graphs of rational function of the type ax plus b divided by cx plus d, correct? So have you tried some questions based on this?
Yes.
Any difficulties so far?
No.
Okay. So what I thought is that we'll have a quiz based on what we have learned in rational functions, and whatever we have missed, right, we'll understand in today's lesson. So that is very important. Let me share with you the lesson which I have prepared. It is basically a quiz on the rational function, which is quotient of two linear functions, ax plus b over cx plus d. Both of you can see my screen, right? Correct. So we learned how do we find x-intercept, y-intercept, vertical and horizontal asymptotes, and how do we write domain and range of the rational functions. We also learn how do we write equation from the given conditions. Well, from the graph we learned last time, and how do we sketch the graph of rational function, correct? Today, we will actually work more on these two topics, which is how do we write equation from given conditions, and also how do we write the transformations of rational functions. Is it okay? That we did not cover so far. But before that, I thought let's have quick quiz on our learnings. So I'd like you to actually go through these questions and answer them one by one. So I'll take you to take turns. We will consider the function 2x plus 6 over x minus 3. So you can write down in your notebook the function 2x plus 6 over x minus 3. Okay. Based on this particular functions, we have 5 questions here. 4 you can see on the screen, correct? Basically, we'll just find the different parameters, characteristics of the graph, I could say. So first thing, how can you tell me, this is a multiple choice question, can you tell me what is the x-intercept for f of x, which is 2x plus 6 over x minus 3? So what is the x-intercept out of the choices given? Can you tell me which one is the right answer?
D.
D. Now, x-intercept is a point where f of x is 0, right?
Yes.
F of x is 0. That means the numerator should be 0, correct? Numerator being 0 means we have to write 2x plus 6 equal to 0. And when you solve for x, what do you get? You get 2x equals to minus 6, and x is equals to minus 6 by 2. And therefore, you get minus 3 as your answer, correct? Do you see that? Therefore, the correct option should be minus 3. Is that correct? Not D, correct? Is that clear? Perfect. Now, Vishruta, can you please answer question number 2? We need to find the y-intercept of this particular function. So how do you find y-intercept, and what is the y-intercept out of the 4 choices?
To find the y-intercept, I substituted all the x's with 0 in the equation and solved it.
Yeah, what do you get?
I got negative 2.
Negative 2 is correct. So when you substitute 0, 2x becomes 0, this becomes 0. 6 divided by 3 is negative 2. That is perfectly fine. So question number 3, Hamza, find the vertical asymptote for the function. So find the vertical asymptote. What is the equation of vertical asymptote? You're on mute. You're on mute.
Sorry, what I was saying was to do that, I'd make the denominator equal to 0.
Perfect.
So that would leave me with the answer of, wait, why is there 2 questions? Both have the same answer. Oh, okay, I see.
Right.
Okay, we put a trick. Okay, I think it's D.
A is correct. X equals to 3, vertical line. The equation is x equals to 3.
Oh, okay.
Yes, sometimes people write y equals to 3 vertically. What is it?
I didn't even see. I just thought it was a 3.
Yeah, x equals to 3 is the vertical line, and that is the vertical asymptote. Vishruta, next question for you. Find the horizontal asymptote for the function f of x. So what is the horizontal asymptote?
It's the highest coefficient, so it's 2.
2 is correct. So basically, which equation? Y equals to 2, correct? It is a horizontal line, y equals to 2. Do you see that? So we basically take the ratio of the coefficients of these two terms. The ratio is 2/1, and 2 is the correct answer. Perfect. So, this is kind of important, a good review on this, and it's a very important question. It will be asked in the test. Now, can you tell me which graph matches with f of x? Which is the right graph from all the characteristics which you have done? Tell me.
2x plus 6. Let's see. Vertical asymptote. Where's the vertical asymptote?
So vertical asymptote seems all are 3, right? X equals
Yeah,
to 3. Vertical
that's
asymptote, this is 3, right? This is also 3. So as far as vertical asymptote is concerned, the vertical asymptote is 3 for not for this,
everyone.
right? Not for this. So
Except for
this
now.
cannot be the right answer. Okay.
Now the horizontal asymptote.
Okay. Horizontal asymptote is what? Tell me.
Is it a little easier if you can just draw it and then I can tell you?
Yeah. Horizontal asymptote of 2, right?
Yeah.
So, well, this is a very close horizontal asymptote of 2. Let me just tell you, because this is horizontal asymptote of 2, right?
Yeah.
So that seems to be the right graph. Is that clear? Secondly, when this is positive, that means you're looking for this kind of thing. Is that correct?
Mhm.
So 1/x type of a figure, right? It is not negative. Otherwise, this will go there. Correct?
Yeah.
So we got to have option 4 as the right option. And I think what you did was perfectly fine. Check the asymptotes. That is simplest. If the asymptotes match both, then check for x or y intercept. Is that okay? So
Yeah.
those are the characteristics which we have to look forward to. Now, we have another function here, which is g of x equals to 2x plus 6 divided by x plus 3. Hamza, can you answer question number 6 for this? Find the x-intercept for g of x.
-3.
Why negative? X-intercept means
So you'd want x to equal to 0, right?
Yeah. So 2x plus 6 equals to, yeah, -3 is correct. Yes, A is correct. Sorry, yeah, you're right. Question number 7, find the y-intercept. Can you please tell me, Vishruta? Y-intercept.
Yeah. It'd be 2.
Correct. Hamza, the vertical asymptote for g of x.
Okay, so vertical asymptote is making the denominator equal 0. So that would be equal to x equals to -3.
9. Correct. Vishruta. Horizontal asymptote. Correct. Now, not correct.
Oh.
Let me tell you why this is not right. Hamza, can you tell me this answer is wrong? Why this answer is wrong?
Okay, so
And this is also wrong.
Oh, right.
Yes. Tell me why that is also wrong. This is very important question. Anybody? Vishwata, think why both these answers are wrong. We do not have vertical asymptote in this case. Let me explain you this particular case. If I take 2 common in the numerator, I get x plus 3. Do you see that? And in the denominator, we already have x plus 3. So x plus 3 cancel, we get 2. And of course, x is not equal to -3. There is a restriction. You get the idea.
Mm-hmm.
So that means if it is just 2, we do not have any vertical asymptote. And therefore, the correct answer for D is none. Do you see that? There is no vertical asymptote in this particular case, because what do we have? When we cancel, we actually get a whole. So if I sketch this particular graph, this graph will be a horizontal line, which will be y equals to 2, but at x equals to -3, we'll have a whole. That will be the graph of this particular function, and this is at -3, the value is 2. So that whole means it is not in the domain, and therefore we have to write that x is not equal to -3. You get the idea. Vishruta, do you understand this example?
I understand.
Perfect. So therefore, do not rush in answering your question. Correct? you have to factor in this particular form and check, do we have a hole here? Do we have a common factor? So if we have a common factor, in that case, that cancels. You get the idea? And it leads to a hole as shown in this particular case. Since now the function basically becomes equals to 2, where x is not equal to -3, so it is a constant function. You get the idea? Very important question. So now find the horizontal asymptote. Horizontal asymptote means if x is approaching infinitely large value, y has to approach a value, right? In this case, if you say 2, it has to approach 2, right? But it is not approaching 2. It is at 2 already. Do you get the idea? Therefore, it does not have any horizontal asymptote also. Because it is 2, right? It is not approaching any value. It's a constant. Correct? So when x approaches infinitely large value, then the y also approaches, it is 2, constant. It is not approaching, it is there.
Yeah. Yes.
Very, very important question. And that could come in your test and you can make a huge mistake. You get the idea? Now, Hamza, can you tell me what is the domain of this function? In its domain, read the question, Hamza. Very interesting question.
In its domain, the function g of x is, I think it's going to remain constant.
You are correct. So that is the function. It remains constant. It is not increasing, not decreasing. All other rational functions which we dealt with, they're either decreasing in their domain or they're increasing. You get the idea? But if they cancel out and you are left with a constant, in that case, it is neither increasing nor decreasing, correct? So make a note of this very important question. And based on this, I'm not sharing with you some true and false. True and false, people think they are very easy questions. But now read and answer. Okay, Hamza, can you please read question 11 and answer?
Let's see. The equation of the form ax plus b over cx plus d will always have a vertical asymptote.
True or false?
True.
False. It can have a hole. We just saw it, right? Remember, it had a hole, right? Vishruta, next question. Question
Wait,
number
sorry.
12.
So for this question, how would you cancel it out so you get a hole? What would you do to this
It is a
question?
general, the question is, the equation of this form will always have a vertical asymptote, right?
Oh, okay. I thought it was only that equation given.
Always have. So A or B, no. We could have a common factor which will cancel away. You have to explain. So it is also a part of communication question. You understand?
So basically, what you mean? It's not that specific question. It's just it's a form.
Yeah, always means whatever value of A and B you define, it will always have.
Okay. Then it's
right?
false.
But no, we just saw an example. We saw an example where we have a horizontal line. There is no asymptote, right?
Yeah.
So that makes sense. Therefore, I made this question paper for you to understand the concepts. Vishruta, please read question number 12 and answer.
The equation of the form ax plus b over cx plus d will always have a horizontal asymptote.
True or false?
False.
Read 13 also, Vishruta.
The equation of the form ax plus b over cx plus d will always have x-intercept.
True or false?
True.
False. Did you see? It has no x-intercept. Is there any x-intercept? You see that? It does not have an x-intercept. It is very difficult to digest. Let me tell you very clearly, I've seen these test papers where every student has got these questions wrong. Because you think, well, how come? You get the idea. But now we have seen the example. Okay, Hamza, question number 14, please.
The equation of the form ax plus b over cx plus d will always have a y-intercept.
True or false?
False.
True. It had a y-intercept. You see, it was a horizontal line, so it had a y-intercept.
Oh,
You get the idea. This is the y-intercept.
okay.
You understand? Okay, Hamza, read the next question. Question 15.
Graph of of ax plus b over cx plus d may not have any horizontal or vertical asymptotes.
True or false?
Uh,
May not have any horizontal or vertical asymptote. True or false?
True.
Correct. It may not have. We just saw it. So
Mhm.
if this is your question, and the question is to communicate or explain or provide example, then we have a perfect example right there. You can write very clearly equation like 2 times, let's say anything, right? Doesn't matter. 2 times x plus 5 over x plus 5. Now this equation, x plus 5 cancel. So it has a restriction that x is not equal to minus 5. However, it is a straight line. Do you see that? At
Mhm.
y equals to 2. And this has no x-intercept. This function is not increasing, not decreasing. It does not have horizontal asymptote, and it does not have vertical asymptote.
Oh,
Is this point clear to you?
oh, okay. So it's a straight line. So okay. So then it can
Horizontal.
have intercepts too. Okay. So it only has
Yes,
one.
sir. Yes, sir.
Okay.
Most of the books and most of the teachers do not tell you this particular point. And
Oh,
therefore, 90% of the students get these questions wrong. And that is why I'm sharing with you. I don't want my students to make these mistakes.
okay.
Got it?
Okay.
So, question number 16. Now we will learn transformation, which we did not learn, but now we will learn transformation of rational functions. Hamza, can you please read the question?
Transformation of h of x from the parent function f of x equals to 1 over x. The transformation of f of x of h of x equals 2x plus 4 includes.
Yeah. What all? Which of them is correct? Is it a vertical stretch by a factor of half? Is it horizontal translation of 4 units left, vertical translation 2 units up, or horizontal translation of 4 units right? Which is correct?
So just by process of elimination, I'd want to eliminate C first
Okay.
because I don't think that's the correct answer. It's not a
Okay.
vertical translation of 2.
Okay.
Horizontal translation, 4 units left. Okay, eliminate A2
Okay.
because there's always obviously a transformation of 4.
Hmm.
Horizontal translation. Isn't there 2 transformations here? What?
So read. One is towards left, one is towards right. One of them is correct. Which is right? Easy, right?
No, I was thinking because isn't there 2 transformations here? It's a 2 and then x plus 4.
No,
So
one transformation is that vertical stretch of 2. I have not written that correct answer. You understand? Out of the 4, there is only one correct answer. So I wrote vertical stretch by a factor of half. No. It is stretch by a factor of 2, not half. Half is a compression even. Otherwise, right? So I have not written. Those are wrong options. What is the correct option? This is what we are trying to figure out. Correct? Only one correct out of 4. Which one is correct?
I'm gonna go with D.
Correct. So it is 4 units towards left. So
Okay,
sorry. B is correct. It is 4 units left. So we have 2 over x plus 4, right? That means the function has been translated 4 units left. You see that?
Yeah.
Where will you get vertical asymptote? At minus 4, right? So as far as 1 over x is concerned, in that case, see, Vishuddha, do you agree with me? As far as 1 over x is concerned, 1 over x is this graph. Is that clear to you? But as soon as I make x plus 4 in the denominator, in that case, what happens? In that case, the vertical asymptote shifts to minus 4, right? So the graph will be what? Graph will be kind of like this. Do you see that? So it shifts towards left. And therefore, the right option is option B, correct?
So, sir, in this case, would the next question's right answer be C?
Okay, next question is very tricky. Let's work it out. Next question. The transformation of h of x, we have to go 4 over 2x minus 4. Tell me, what is the horizontal transformation? Yes, Hamza, tell me.
4 units, right? Minus 4.
Wrong. Vishruta, can you tell me what is the transformation here?
The horizontal translation of 2 units.
Oh, shoot. Okay, yes, because you factor it. Okay. I think
Because
you're
you
right. Yes.
factor it, factor it,
Yes.
factor
Yeah.
it. Remember,
So
remember.
it's D.
Correct. So 2 units right. So you have to factor it. You have to
Yeah.
be very careful. Losing marks is so simple. 0.5, 0.5 gone. I mean, for nothing, correct?
Mhm.
Okay. So you have, don't forget, if there is a term like this, you have to factor before writing the answer for horizontal translation.
Okay.
First, now we are doing descriptive type of questions, and let me tell you, this is not easy. You will just realize. Okay, describe the transformation 2x plus 6 over x plus 4. I would like you to write down the transformation in your notebook so that we can discuss your answers. Is that clear? So take 2 minutes, write down all the transformations, basically, vertical stretch compression, horizontal stretch compression, and translations. Right? Tell me, how will you answer this question?
Okay.
We are comparing with the graph of 1 over x always, right?
Okay.
So whenever you're ready, just tell me and then I'll write down whatever your answer is.
Factor.
Yes, yeah, tell me.
Got horizontally 4 units left.
Okay, 4 left horizontally. Okay, 1. Then
I got stretch / compression 2 units.
vertical or horizontal?
Horizontal.
Explain again. You got what? Tell me again.
2 units stretch or compress horizontally.
How can you say both the things? Stretch or compress 2 units? No, no, no.
I wasn't sure. I think it's stretch.
Why? Why do you say so?
Because I feel like it was a compression, it would be 1 over 2.
Okay, so 2 is in the numerator. It is not with 1 over x kind of a thing, right? Okay, but you said stretch or you want to say horizontal, correct?
Yeah.
So 4 units left is correct. That is no doubt. Because of this, we have that, correct? But stretch or compressed by half or 2, you are saying this, which is horizontal, which may not be right. Any other transformation?
Vertically 3 units up.
Vertically 3 up. Okay. Okay. I don't think these are correct. Hamza, what answer do you get?
Oh, I started by solving question 19 because that was a little easier for me.
Okay,
Can I do
tell
that
me
one?
question 19. No problem. Tell me. Yeah, that
Okay,
is
so
straightforward. Yes, yes. Tell me.
okay, so first transformation I saw was vertical stretch by factor of 3.
Okay, second.
So second is horizontal translation left by factor of 2.
Okay, 3.
And then third is 1 unit up.
I think these are not correct. And I don't think they are correct. You are comparing with 1 over x, correct? So if you compare with 1 over x, you see something here, which is like half of x even if you factor this, let me just rewrite this, right? 3 over half. I have to, you remember, we have to factor this, correct?
Oh
If
yeah,
you
okay, I
factor
got it.
this, you
4.
get x
Yes.
plus
8.
4 becomes
Yeah,
8.
8.
8,
Okay.
right? And then you have 1 here. Is this correct?
Yeah, so it'd
You
be left
understand?
by a factor of 8.
So it is moving left by a factor of 8.
8.
So that is one correction for sure, right?
Mm-hmm.
Now, if we have half here, that means it is horizontally stretched by a factor of 2, correct? It is stretched by a factor of 2. Is that correct?
Yep.
Right. So if there is a stretch, then horizontally, we'll have to rewrite this, of course, right? But you understand. Uh, another very important thing is when we write transformations, we have to follow an order. You get the idea? We have to follow an order. Order means first with stretches, compressions, and reflections. Stretch, compression, and reflection, correct? And then we do translation. That is the order which we should follow when we write down the transformation. Is that clear to you?
Yeah.
Always. Because that is the order in which you are going to sketch your functions. Is that clear to you? Correct? Okay. So the order will be, I could go with horizontal stretch by a factor of 2. Is it correct? By a factor of 2. This comes from this place, correct? Then I factored it out, and I do have 3 on the top, and therefore I'm going to say that it is vertically stretched by a factor of 3, and then you will say that, well, this has moved 8 units left, right? Translated 1 unit up. Is that clear to you? Right? So that becomes the right kind of transformation. Now, the thing is, how do you write transformation of the function given in the form of ax plus b over cx plus d? It is very difficult. So, Hamza, you did the right thing that you went to question number 19. Try to write down the transformation, right? So, basically, that is what you have to do. You have to write this rational function in that form. You get the idea. Then you can read the transformation very easily. From here, you cannot read this transformation so easily, correct? You can make out. How can you make out? Horizontal asymptote is at 2, right?
Yeah.
That means for this, the horizontal asymptote is y equals to 0. That means vertically it has gone up by 2 units. You can say that, right?
Yeah.
So translation, you can say that 2 up, right? And then you can say 4 left. You can say that 2 up and 4 left, correct?
Yeah.
Now, what is the stretch factor? You will say 2 is the stretch factor. You will say that, correct? Looking at the diagram. But let us rewrite this in the form which I have written. Now, that is itself a very difficult step which many students do not understand. I will show you how to easily write down this in that particular form and get the answer. Okay, denominator is x plus 4, right? So
Yeah.
I will, how did I get 1 here or 2 or any constant? Because that denominator got cancelled. So that means I need to have this as 2 times x plus 4. If I can make this 2 times x plus 4, what do I get? I get 2x plus 8, right? But what do I have? I have 2x plus 6. I don't have 8. Oh, to make it 6, I will do minus 2. Is that okay? Now, my numerator is same as the numerator given above, before, correct?
Yeah.
Therefore, I will write this as equal to, let me change the ink. I will write this as 2 over x plus 4 minus 2 over, sorry, I will write this as 2, right? Because this and this cancel, correct? So I write 2 minus 2 over x plus 4. Is that clear to you?
Yeah.
It gives
Wait,
you,
sorry. I'm
yes.
just confused. How did you do the step? How did you get 2 over x plus 4 minus 2 for the numerator? I get. I feel like did you just cancel the numerator denominator? But where did the 6 go? And like,
2x plus 6, I
Yeah.
added 2 and subtracted 2.
Okay.
Why did I do that? Because I want x plus 4 as a factor. So if I could do like this, think like this, we have to get cancelled these two terms, x plus 4. If I need x plus 4 as a factor, 2 times 4 is 8, but I have a number 6. How can I make 6 as 8? I could add 2 and subtract 2. Is that clear to you? Technique.
Okay.
This is a technique. This you call tips.
Mhm.
Noted?
Okay.
Okay. Now I will do like this. Well, this is 2x plus 8. So I can take 2 common and write within bracket x plus 4. That was the whole idea, right? And minus 2 remains divided by x plus 4. Correct?
Mhm.
Now, I could actually rewrite this rational function as 2 times x plus 4 divided by x plus 4 minus 2 over x plus 4. This cancels, so I get 2 minus 2 over x plus 4. Do you see that?
Yeah.
Now you will write down the transformation. Do you see one unit? Reflection minus means the graph has got reflected on the x-axis, correct?
Yeah.
Now you tell me what is the transformation of this function. So first is reflection on x-axis. You can never get that answer directly from the given equation. You get the idea? You got those things correct. 2 up and 4 left. Yes. And also stretch of 2 you got correct. But this critical information has been missed if you do not split it. And therefore, your graph will be wrong. You are going to sketch a graph which is like this, but actually speaking, it will be the other way, right? It will be kind of like this, right?
Yes.
It will be reflected. So you'll get everything wrong in this particular question. And that is how, if I set a paper, I will ask a question. You get the idea?
Mhm.
So that is how you have to answer this particular question. Okay?
Okay.
Very good. So now, question number 20. Hamza, please read and answer this question.
Transformation of h of x from the parent function f of x equals to 1 of x.
Oh, I should,
Right.
it is not on transformation. It is on graphing. Yeah. Question number 20. Read.
Write the function in the form of f of x equals to ax plus b over cx plus c that needs the following conditions and sketch the graph. Vertical asymptote at x equals to 2.
Okay.
Horizontal asymptote at y equals to -1. X-intercept at -4 and y-intercept at y equals 2.
X-intercept at -4. Y-intercept at 2. So sketching the graph is not very difficult. At least that marks we can get without any problem. Do you see that?
Yeah.
Let us first sketch the graph. What I'm trying to tell you, these type of questions can be tricky. But if you systematically read vertical asymptote at x equals to 2, there you go. Horizontal asymptote y equals to -1, y equals to -1. X-intercept -4, right? Y-intercept 2. So we got full marks for graph. Is that clear to you? Full marks already with a neat and clean sketch, right? X and Y right here.
Yeah.
And now we will say, write down the equation. Now you have to write down the equation. Tell me, what is the equation for this particular graph?
So I'll do it step by step.
Yes, sure.
So the vertical asymptote is x equals to 2. So that would mean that the denominator, when you plug in something that's equal to 2, right?
Yes.
So we can do x minus 2, yes.
Correct.
And the horizontal asymptote is y equals to -1. So when we divide the top term by the bottom term,
Yes.
it would have to equal negative. It would have to equal to -1.
So you can write negative x, right?
Yeah.
Okay, then
-1.
x-intercept of -4.
Okay, x-intercept of at 4. We can we just do +4?
So x-intercept
I
means
feel
y
like
is 0. So if I equate -x plus 4 to 0, I get x equals to 4. So it should be -4, right?
Sorry, yeah, -4.
Correct? Does it make sense? Now you
Yeah.
have to check y-intercept of 2. Is that satisfying? Y-intercept of 2 means you will put 0, 0 here and you get 2, correct?
Mhm.
So you get f of x equal to this, and this is the right answer. Is that clear to you?
Yeah.
Perfect. That was simple. Now, 21. Vishruta, I'd like you to try this the way Hamza did his question. Tell
Okay.
me. Read first.
Write the function in the form f of x equals ax plus b over cx plus d that meets the following conditions and sketch the graph.
Correct. So you will start by sketching the graph. Do you see that? Start by sketching the graph. Don't go in that order in which teacher wants you to. It's a trap, okay? So first sketch the graph. It is a trap. Okay, now sketch the graph. Read and sketch. Tell me.
The vertical asymptote at x equals 3. Horizontal asymptote at y equals -3. X-intercept at 2.
This is 3, right? So 2 will be here, correct?
Y-intercept at -2.
Clear. The only way to sketch this graph is, it is kind of 1 over x. The only way to sketch this graph is this. Is that clear to you? So we have got half of the marks of the question in no time. Is that clear to you? And just label -2 and +2. Done. X and y axis. Okay, so we have done this part. Now write down the equation. Tell me. Start from vertical stretch. Tell me.
Cool. So that would be D3.
Yeah, horizontal. Now tell me, horizontal asymptote -3. What will you get in the numerator?
3x.
Okay. X-intercept of 2. Add 2 x-intercept. What will you get?
+2 on the numerator.
No. X-intercept means y numerator should be 0 for 2, right? So let us say this is b, right? So you will say, well, -3x plus b should be equal to 0 for b equals to 2, right? You get the idea? So,
Okay.
so you get the idea, right? So I want the value of b so that -3 times x-intercept is 2, right? So if I put 2 here for x plus b, I should get 0, right? So b is equal to 6. Do you see that?
Yeah.
So I'll write 6. This is how you're going to get the numerator. So this is the right order to proceed to get the equation. Now, y-intercept of -2. Do we have y-intercept of -2? X equals to 0? Yes, we do, right? So it is correct. So you get the equation f of x. Does it make sense to you?
Yeah.
So I will prefer first you sketch the graph. At least get that mark very clear, because graph will help you to get the equation also at times. Second, go with system, vertical, just the order of operation. Do you understand? Multiplications first, right? And then translations. So those x and y intercepts are translated, correct? Normally, 1 over x will not have any x-intercept or y-intercept, correct? It is a, horizontal and vertical asymptotes. So I hope this concept is absolutely clear. How do we get these things? Okay, I will just review. How do we find horizontal asymptote algebraically? Correct? So we had a couple of examples on finding horizontal asymptotes algebraically. The idea was that you have to factor out the x and cancel it and then find the answer, correct? But today, since you did great work and we already have 15 more minutes, I'll now teach you how do we find horizontal asymptotes.
Sir,
Yes.
I'm not really sure if I read this. I think I read this in one of the textbooks. I was doing some of the questions the other day. And the way like I don't know if this is the right way, but when the powers are equal, when the coefficients power are equal, we can just divide the first term by the second term. But when I think when the power of one is bigger than the other, then it becomes like the x in the horizontal line or something.
You are correct. That is what I'm going to discuss, right? So I should not say horizontal asymptote. Let's be very clear about it. I should say end behavior. End behavior really means when x approaches infinitely large, then what happens to y? And when x approaches infinitely large, but negative value, then what happens to y? This is what we are interested in, correct? Now, as you know, the rational function could be written as some numerator over some denominator, correct? Everything has to be polynomials, and clearly the denominator is never equal to 0. Is it clear? Because that is going to give us the restrictions, vertical asymptote or a hole, which we have seen. Now, there could be numerator and denominators are polynomials. So let us say that the degree of numerator is n and degree of denominator is d. These are the degree. That means if I write a polynomial, which is, let us say, 2x to the power of 5 plus 3x squared plus 4, let us say, divided by x to the power of 4 minus plus 3, right? What is the degree of this polynomial? 5 in the numerator, correct? Degree of denominator is 4, correct? So we are talking about the degree of polynomials. As you know, this degree decides the end behavior, correct? And therefore, we have to only check the degree of numerator and denominator to get the equation of horizontal asymptote, if it exists. Is that okay? So there are three cases. One, we know that numerator degree could be less than denominator degree, correct? Numerator degree could be equal to denominator degree. Numerator degree could be greater than denominator degree, right? These are the only three cases, correct? Is that right?
Yeah.
Either the degree is lesser or equal or more. What else? Less than means, let us take an example. Less than means I write 1 over x plus 5, right? So what is the degree of numerator? 0. What is the degree of denominator? 1. So in this case, always the horizontal asymptote will be y equals to 0. Is that okay? Like 1 over x. Is that clear to you? Now, same degree means I could have 2x to the power of 5 plus 3x cubed plus 5 over, let's say, 3x to the power of 5 minus 4x, correct? Now, in this case, you find that the degree of numerator and denominator is same, right? In that case, the horizontal asymptote will be y equals to the ratio of these leading coefficients, 2 over 3. Is that clear to you?
Yeah.
That is the rule. Now, third case, if the degree of numerator is higher, let us say we have x to the power of 5 plus 6, and here we have x to the power of 4 minus 3. Now, degree of numerator is higher, right? So in that case, no horizontal asymptote. Is that clear to you?
Yeah.
Vishruta, is this point clear?
It's clear.
Horizontal asymptote will exist only if the numerator degree is lesser or same as the denominator degree. Is that clear?
Yeah.
Otherwise not. Let's look into a special case when the degree is greater by 1, right? So let us say we have this particular example. In this case, we will have an oblique asymptote. So if I divide equation x plus 5 by 6, this is denominator, right? Divisor, correct? X plus 4 minus 3, what will I get here? I will get a linear term, right? Linear term, correct? This linear term is the equation of the oblique asymptote. because the function is going to approach this line. It can approach from top or from bottom, but it is going to approach, and therefore it qualifies the definition of asymptote. We are approaching a value. Value here is the line. You understand? So we call this as an oblique asymptote. So if the numerator degree is equal to denominator degree plus 1, it is only one higher, then it approaches a line, and therefore it is called an oblique asymptote. Is that clear to you? So new term, oblique asymptote. Is that clear? If the degree is n equals to d plus 2, in that case, it also approaches a graph. But which graph will it approach? Parabola. So in that case, this, because now the numerator will be a parabola, correct? Maybe like this. So our function is approaching this parabola. You understand? So it is asymptotic to a curve which is of degree 2, which is a parabola, right? But it is not an oblique asymptote, okay? It is not an oblique asymptote. Oblique asymptote exists when the degree of numerator is one more than the degree of denominator. Is that clear? Oblique asymptote is very important. Perfect. But if the communication question is that if it is two more degree of numerator, then what will happen? Then it will approach the parabola, because then when you divide, the quotient will be quadratic, correct? Is that okay? Quotient will be quadratic. So function will approach the quotient, which is quadratic in nature. Okay, this is important. Now, last question for you. If a graph rational function has an oblique asymptote, can it also have horizontal asymptote? Yes or no? Tell me. If f of x has oblique asymptote, can it have also, let me write, have horizontal asymptote? Yes or no? No, because horizontal asymptote will exist only if the numerator degree is either equal to or less than the denominator degree, correct? And oblique asymptote will exist if numerator degree is higher, right? At least by 1, it is denominator plus 1. So therefore, both will not exist together. Correct? Correct?
Yeah.
But other combinations, horizontal asymptote and vertical asymptote, can exist together, right? Whole and vertical asymptote can also exist together. Let me give you an example. Y equals to x plus 1 times x plus 2 divided by x plus 1 times x minus 1. I will normally write it as x square minus 1, right? But when you factor, you get x plus 1 times x minus 1 in the denominator. So in that case, x plus 1 will vanish. So we have a whole at x equals to minus 1. And this will give you a vertical asymptote at x equals to plus 1, correct? So we see that we have a whole also, we have a vertical asymptote also, and we have a horizontal asymptote because this ratio is 1, correct? So we have a horizontal asymptote at x equals to 1, correct? So all the three things are existing together. That is a horizontal asymptote, vertical asymptote, and the whole. You get the idea. So that is possible. So today's lesson, we have learned that in rational function, it is possible that we may not have any asymptote, right? We may not have any asymptote. We may have any one of these asymptotes. We could have combination of these asymptotes with wholes. And if we have oblique asymptote, then we cannot have horizontal asymptote. Is that clear to you?
Yes.
You have to summarize this in your notes, right? Very important. Watch my video once again to understand today's learnings. Since these questions are some way or the other appearing in your test paper, they may come either as a communication question or as a multiple choice true or false question, which people think are easy. They are not that easy. Okay? Correct? Good. So I'd like you to summarize today's lesson now. Okay, Hamza, what did you learn today?
Um, I never before this day thought that rational functions couldn't have asymptotes, both vertical and horizontal. I learned that today. Um, I didn't really do transformations for a while since the second or third unit, so that was good review. And the factoring stuff, that was also really nice. I had no idea you could do that for rational function, completely went out of my mind. So I think I'm gonna be more careful now and look at equations and see, okay, is there a hole here? Is there not a hole here? So I think I'm well prepared for that now. So
Good job. Good job. And how about you, Vishwata?
Similar to Hamza, I didn't know about the factoring. I didn't know you could factor in these rational functions. I learned the horizontal and vertical asymptotes with the hole and all the crossing out, the factoring. Yeah, it was very helpful.
Very good. So with this, we kind of midway between the rational functions, but we have covered the major part, right? I've also exposed you to the oblique asymptote. You already know how do we divide the polynomials. So dividing a polynomial by the other, you get a quotient. If that quotient is linear, then we have an oblique asymptote, correct? And that will happen only if the numerator degree is one higher than the denominator degree, correct? And you learn horizontal asymptotes will exist only if the numerator degree is either equal to or less than the denominator degree. If it is equal to, then the equation is the ratio of leading coefficients of numerator and denominator. And if it is less than, then y equals to 0 is the horizontal asymptote, just as we have in y equals to 1 over x, correct? Perfect. So with that, we'll end our class today. But I'd like you to do some questions from my playlist on rational functions. I think now you are in a position to answer almost all the questions on this unit. Okay? Great. Thank you and all the best.
Bye, sir.
Bye.